All right, your backend is too complicated. I've said that before.
If I told you right now to go and build me a backend API for a new project idea, what language would you choose? Probably.
Right now, to be completely fair, I would probably choose Go, Rust, or Zig. Now, some people choose Elixir. I do need to investigate Elixir. Maybe Elixir needs to be my 2025 language. What do you guys think about? What do you guys think about that one? 2025 Elixir? I want to use Elixir. But I also don't like doing functional languages on stream because y'all get so confused at functional languages. It's really unfun to do on stream because it is just genuinely difficult for a lot of people to follow. It just is. And so it just turns into a whole, it turns into an entire chat skill issue. It is a chat skill issue. Just use C# already, you scrubs. Okay, we're moving on.
Probably something you're familiar with, but that could still get the job done, like Python, TypeScript, or Go, right? But now I need you to cache external API calls, maintain multiple caches, and manage a long-running background process that reads and writes from these caches at regular intervals. Suddenly, you've added Redis to your stack, along with a background processing library. And some of you have already started thinking about microservices. I can tell. You're all done?
My favorite Twitter trope of the super duper modern backend engineer is that you have more microservices than you have users. I think it's completely fine not to have microservices. Yo, dog, just build the application. Okay? Do you really want to spend all of your time going that hard on your architecture when 99% of all startups fail? Maybe, just maybe, build the gosh dang thing. You know what I mean? Maybe, just maybe. Right tool for the right job.
Welcome to Costco.
My bad. I left alerts on. Use the right tool for the right job. Hey, by the way, can I say something? You know how I know that I finally made it? You know how you know that I finally made, I've actually made it? DHH follows me, okay? My based takes have finally achieved stardom level. Okay, that's how I know I've made it. All of this shitting on TypeScript finally got me somewhere. Okay, he quote retweeted me. Oh, I didn't even know that. Anyways, I genuinely agree. I actually do want to get DHH on here. I think I would love to hear his opinion because I know we're completely off the rails at this point, but there's this one that I love this tweet and I want to know more about it. This I find to be one of the most compelling takes on Twitter today, which is do the things that you think are beautiful. There is something really important about that I think people don't take enough time to think about, which is that it's so good to be it's so good to be driven by beauty. You will find yourself using and programming so much longer. And the best part is beauty is totally on your behalf. And so if you love type masturbation and you love programming and just having the greatest types, I honestly think that that's okay. That's why we sort our docs by sidebar length. Yeah, exactly. Wow. I do want to get him on here. I love this. I genuinely like this take. Right? I think there's something very true about that. Hey, Dax.
Great. I have one final requirement. This API must never crash. Damn. Time to rewrite it all in Rust, I guess. As with every problem in software.
I think you just need to rewrite it in any language that has errors as values. I think that's just the real big thing is that as long as you have errors as values, you will never have you'll generally never have a problem. But B, I don't believe in the thing it cannot crash. I think crashing is a great way to send a message that you have fundamentally violated your program's principles, and you should be able to do that. Effect TS doesn't work though. That's the thing. So people always say this, effect TS, you have to wrap everything in effect. Right? You have to. It's an all or nothing library. There is no middle ground, right? Let it crash, Erlang. Yeah. I think there's something really good. Errors as values and happy crashing. You have to, everything has to be wrapped in effect for you to be able to be safe from it, right? And but then again, you also have just all these other problems. If you were to crash in some sort of async handler, you also have to have top level uncaught, uncaught rejection and uncaught exception. So there's also a second level in all TypeScript applications where if someone has an error, it will be a problem on the outside. So that's one thing that's really, really good in general about errors as values languages. And effect you cannot do. Effect helps the problem, yes, but it doesn't fix the problem. Myths. Yes, effect will not make your code that much slower. I agree. It would never make your thing much slower, but it will make your code slower. It will make your code slower. It will cause more garbage collection. It will cause more of that. And if you're trying to build a long running service, this would be problematic. If you're just building Lambdas, you don't care about your application and how good or performance based it is. You only care about startup time, which again, great argument to avoid having libraries. Like real talk, if you want fast startup time, have less JavaScript. Like that's not a crazy take. So for me, it's just that I'm not going to personally. Prime knows about Lambda. I know the basic idea of it. Okay, it's not like it's crazy hard. Thing needs to run. Less JS equals more performance. Exactly. So wrapping every call in a try catch makes it slower because you have to understand how a try catch works. I know, but this is silly. 99% of people's concurrency problems are extremely simple. Okay, this is a crazy take. I see this all the time. The effects people are always just like, oh yeah, well what happened if you have to deep bounce and then you also have to throttle and then you also want exponential back off on a single request call? I'm like, yo, maybe just maybe you're making a very crazy API. Okay, maybe you just simply need a promise.all settled. And if something fails, you just got to handle the thing that failed. Like maybe that's not the crazy thing to do. Okay, this idea that all of a sudden you need to be able to handle all these crazy timing situations and you're a CRUD application, I'm kind of calling BS on that one, okay? I just am. Use effect.ts because you want a bunch of functional composition. Don't use it because you're like, oh, I'm going to need all these async handling. 99% of the time, you never need that. Okay, and the 1% of the time you actually need, like, say, an async request queue, writing 15 lines of code to write an async request queue, not very difficult. Including a whole ass library just to say that you only want 3 parallel requests at any one time, a little ridiculous, okay? A little ridiculous.
There is a better way, a way you can handle everything I've just mentioned with one tool. You've seen the title by now, so you already know I'm talking.
Gleam. This seems like a very interesting language. I really liked their approach to everything. I've only read a little bit about it, but I genuinely liked the syntax. I liked the ideas. I would like to, part of me wants to invest more into it, but I have a general rule of thumb, which is if Dylan Mulroy loves it, I probably won't love it, but I love Dylan. Like that's the thing is that I think Dylan is a fantastic, amazing engineer, and anything he builds I think is extremely talented, but I just probably won't like it. I'm just saying, okay? I just probably won't like it. It's just not for me. I'm not that kind of guy. Shout out Dylan Mulroy. Yeah, dude, absolutely. Give the man a shout out. Go follow him. He's super talented engineer. I don't say that out of a like a negativity. I think he's so good. Look at that. I even follow him on Twitter. It's just different brain. Different brain. I'm not that brain. That's it.
Talking about Gleam, the type-safe, simplicity-first language expertly baked for massive concurrency, high availability, and effortless scaling. If you're not already sold, give me a few minutes and I'll show you just why you should be writing your next API in Gleam. This is a Gleam REST API written using the Wisp web framework for simulating Pokemon battles, and it has 2 endpoints. The first endpoint, /Pokemon, takes a Pokemon name and returns information on the Pokemon, such as its base stats and available moves.
I do want to take like a quick note here. This is amazing that it's not like a to-do application test. It's actually like a real test. This is super cool. I absolutely love when people make real mock apps. It's actually super cool. I think it really does give you a lot more insight into the language than just these dumb basic apps that most people compare. Like, oh, well, we're going to do a hello world test against each other. And it's just like super cool. Wow. You did 200. It is a PokeW. Pick just wants me to see this PokeW so bad. You can see it. Look at this. He just keeps hitting out that PokeW. You know it. You know Pick is just so hornied up for it. Okay, good. It didn't hit me. I thought somebody might hit me with the Poke.
The second is /battle, which takes the name of 2 Pokemon and simulates a battle between them. Okay, but I can do that in another language. What makes Gleam so special? Gleam has an incredible static type system. It's super simple, but it has proper sum types.
I do like sum types. This is one thing I wish I go back and forth on this. I really do go back and forth on this because every problem that I've ever solved, I feel like sum types is the solution, and I wish Go had sum types. And then sometimes I'm thinking maybe I've created a problem that's more complicated than it's needed, and there might be a simpler way to think about it. And then sometimes I'm like, yeah, actually there might be a simpler way to go about it. And sometimes I do actually find a simpler way that didn't need sum types. But I do love them. Yeah, they are, sum types are pinnacle type masturbation, but they're also they're so useful sometimes.
and no null values. In Gleam, errors are values that are generally propagated using the built-in result type. This makes code more verbose, but it keeps control flow visible and simplifies debugging. For example, here's the logic for the /Pokemon route. First, we check if the Pokemon we're looking for is in the cache and return it if so. Otherwise, we make a request to the Poke API. The use syntax with result.try will return the result if there's an error, only assigning the Pokemon variable and executing the code below if the function call was successful. We do the same with the Pokemon's moves before creating our return type, adding the Pokemon to the cache and returning. The route handler simply calls this method, returning it as JSON if it was successful, otherwise returning an error response with our message. All of this
it's pretty clean, right? Like I do love this style of code. Generally speaking, I do like the result style code. I think that tends to be one of the more nicer ways. It's one of those things that I think that Go, I wish they would somehow figure out how to have a idiomatic way to handle early returns. I still remember you calling some types just an academic thing. I know pick. Everybody knows the arc every programmer goes through, okay? It always starts off as, nah, that's just stupid. Then you start liking it. Then you fall in love with it. And then you realize you probably used it too much. And then you turn, like, it's just the standard curve. Nah, this is bullshit. This is the greatest thing ever. We need to use it everywhere. Actually, maybe there's some middle ground that's nice, okay? I agree. Dang it. Stop calling me out,
Pokemon's moves before creating our returning an error response with our message.
I do like this
All
stuff.
of this code is very simple to read, very simple to write, and doesn't blow up in your face. The code for calling the Poke API is also very simple. We use the Gleam HTTPC library to construct and make a request, and then handle both the request failing and non-200 error codes. Then, we use the Gleam JSON library to pass the result into the API Pokemon type. Since Gleam is statically typed and doesn't support macros or reflection.
You are very dehydrated. False. Okay, look at this. This is actually my second liter of water. Okay, so think about that. Think about that.
We have to manage JSON decoding somewhat manually. The JSON decoder we saw earlier decodes a JSON string into Gleam's dynamic type. Dynamic contains data that we don't know the exact shape of, and we use decoders to turn it into something we can represent in the Gleam type system. In Gleam, a decoder is just a function that takes a dynamic type as input and returns a known type, usually in a result. While more verbose, this allows us to do some validation logic at decode time, rather than having to wait until later. For example, the Poke API returns our Pokemon stats in a JSON array that looks like this. This would not be particularly friendly for our users, so it'd be much.
I do like that. I mean, just hearing that, I actually really like the idea of having a dynamic type supported, so you don't have to, one thing that kind of sucks is when you have to know all shapes of your types. It is just, I mean, that's like why people love JavaScript or Python or Lua or any of these things, because you can kind of like also just make it work, I like that. I like that experience. Sometimes you just need to make something work. And that's that. And so it's nice.
Much better to combine this into a single object that contains one field for each of the 6 stats. Here's a custom decoder that creates an intermediate list of API stats objects containing the base stat and the name of the stat, and then includes that in another decoder to create our.
I did want to see how they handled that. Dynamic field. Oh, interesting. Okay. Okay, so they keep having return values and then no return values. And I'm having a hard time following what they're trying to do. My assumption is this returns a result type. I do like decode 3. Is this going to turn into, isn't there something in, what is it? Is it Lisp that's like, I swear it's something like car, and it just like keeps getting longer with more and more R's? Isn't that a thing? Decode 3, decode 4. I assume decode 3 means you pass in the object. Yeah, yeah, car, yeah, exactly. Yeah, catter. So funny.
Objects containing the base stat and the name of the stat, and then includes that in another decoder to create our desired stats object. Finally, we use our stats decoder in the decoder for our API Pokemon, and we're all set. At this point, you might be wondering, Isaac, how did you become such a god-tier programmer? It was all thanks to today's sponsor, CodeCrafters. CodeCrafters is an online.
What a great ad transition. I'm always so impressed when they do such great ad transitions.
Online learning platform for advanced software engineers. Their courses are all focused around building your own versions of real.
By the way, I actually really like this approach. I think CodeCrafters has done a great thing. I really do. I really do like this generally this approach of building like a project that makes sense.
production-grade software. Personally, I'm fascinated by the technologies behind databases, so I've been learning Rust by completing their Build Your Own SQLite course. Each is run in stages. Instead of being told which functions you need to write and exactly what to do, Codecrafters courses are more open and simple.
I just don't want to see more open and then have that on my screen, okay? Is that just like, can we just all agree on that one? Okay.
Simply link to any relevant documentation for the tool you're building. You then just push your code to a special Git repo that runs some automated tests, unlocking the next stage if they pass. I love this approach because I'm not stuck using a crappy online editor. I can use my Vim, by the way, and I don't feel held back.
You know, I think it's the greatest thing ever to refer to NeoVim as Vim. You know why? Because it is the one true Vim. It's been the one true Vim for a half decade now. It is the truest one true Vim. Okay.
Backed by the slow pace of lots of online programming courses and tutorials. They've even recently released a couple of courses on replicating Redis and SQLite in Gleam. If you're interested, you can sign up using my link, which is on screen and in the description.
There you go. ihh.dev/codecrafters. ihh.dev/codecrafters. By the way, I do like that Gleam was really, really smart. I don't know, or Lewis, I believe that's his name, the creator of Gleam, Lewis. It was very, very smart of him to like get into Codecrafters and get his what's it called? His language as one of the building ones, because it really gives everybody that really fast charge that you know how you can build really complicated things with it. I think it's pretty dang smart.
40% off your plan. And if that's still too much, see if you can have it paid from your company's training budget. Let's talk about concurrency. Since Gleam runs primarily on the Erlang Beam VM,
Black on black, people. Black on black.
Concurrency acts slightly different to how it works in other languages. Instead of running every async function in a single process and switching between them using an event loop, concurrent tasks in Gleam each get their own process, which can be completely isolated from the main process. There are two basic ways to use concurrency in Gleam: tasks and actors. We'll cover actors slightly later, but
I wish I knew more about the actor, like the actor pattern or whatever you called it. I think Tower uses it, right? I really want to know more about that. I really, truly do.
Tasks are essentially jobs that have a single purpose and run to completion. You can collect the results at the end of the task, but typically you won't interact with it while it runs. We use tasks for collecting all the moves for a particular Pokemon. The Poke API only returns a subset of move information when requesting Pokemon info, so we have to call another endpoint to get stats like the move's power and accuracy.
Okay.
To do that, we map over the list of moves using the task.async function from the Gleam OTP library to create a new task for each move. This calls the getMove function, which is just an API call like we saw earlier, and returns a task handle. Then we call task.tryAwait on each handle, passing in a timeout value. If the task returns successfully within that timeout, task.tryAwait will bubble up the task's return value, wrapping it in a result. Then we have some error handling code that generates a tuple containing our moves and any errors that occurred.
The word partition makes me feel like I'm not as smart. Like I know what it means, but in this context, I have absolutely no idea what's happening. Like result.flatten, I totally understand, but this one I just don't, and it makes me scared.
If we had any errors, we return the first one. Otherwise, we return all our moves. You can avoid all the error handling by using task.await instead of tryAwait, but then the host process will crash if the task process crashes. As you can see, this has all been incredibly easy, and you can pass any function to a task. You don't have to mark it in advance using an async keyword. Thanks to this, you don't end up with function coloring in Gleam, and you can write linear, synchronous code and easily parallelize later. It's also worth
I do like that.
noting that you don't have to.
I like that. I do like not having colored functions because, F your colored functions. Okay, Go does a really great job of this. I like that a whole dang. Oh, it's just like I hate function coloring. I hate it. It's one of the reasons why I've largely stepped away from Rust is that I hate lifetime coloring. It has struct colors and function colors, and that can be just such a pain in the ass.
To await the tasks immediately like we do here. You can just leave the task to run in the background and await the result when you need it, even in another function. But come on, Isaac, you said we'd also be able to replace our Redis cache. It doesn't look like tasks are going to help us do that. Well, that's where actors come in. When you're
Everyone says, what is function coloring? Dang it, Ryan Winchester, why didn't you just show up as one of my autocompletes? Ryan Winchester, there you go. This is function coloring. Thank you for having this pinned. I need you to have this pinned at all time for me so I can refer to this at any point, okay? This is a very important, this is like the most important image of this century. There you go. That's function coloring, okay? When one of them's async, they're all async. Oh, that, yeah. Function coloring. It makes you have to call functions all a certain way to use it. And so when one becomes async, they all become async. That's why I said structs have coloring in Rust. When one has a lifetime, all the functions that have it now need lifetimes out of them. I don't even remember enabling automod. But now look, even automod's like, I don't know what you're doing out there.
Writing an API in a language that uses async await or some other implementation of futures, your concurrent functions will generally run on a single process. This means if you create a lot of futures and one of them has an infinite loop of CPU-bound code, it could block other futures from completing. This makes it very difficult to have long-running background processes that can communicate.
I mean, it would, if you had something that creates an infinite loop at any time, even if it's in a different thread, it's still gonna make it massively hard to run your system because you're just gonna be pegging. You're just gonna be constantly context switching and pegging your CPU.
Okay, with the main thread. In these cases, people will generally reach for either an external service, like Redis, or split up their monolith into microservices. The Beam gives us some other options instead. With something like a cache, you typically use an ETS, or Erlang term storage table, which is a concurrent, in-memory data store built right into the VM. However, the ETS API is a little more complicated, and not quite suited for a beginner video like this one, so instead we're going to make a trade-off and use actors. Actors are long-running processes that hold some state, and you can communicate with them by passing messages, which will be processed in a first-in, first-out order. This makes actors a great solution for keeping your apps race condition free, as only one message.
By the way, I really, really want to see, I've been hearing this talk about, and I really hope the Olympics, by the way, really got to make these images bigger, but I really hope the Olympics does do this. I think that they should have one college-level runner join the Olympic run just to see how slow more normal people are. I think that would be fantastic because I want to just know how slow more regular people are comparatively to the Olympics. It'd be absolutely fantastic. Like get a high school runner and a college runner to join in and see where it goes. That poor slow guy, it would look like this. It'd be fantastic.
Messages processed at a time, so the underlying memory is not shared across processes. Unfortunately, actors can't process messages concurrently, so in a production use case, there'd be a bit of a bottleneck. But this is a silly little app for demonstration purposes, so let's take a look at how we can implement a cache using actors. I've created a couple of type aliases here to save my little fingers. A store, which is our underlying data storage for our cache, is just a dictionary with string keys. The cache type we'll be passing around in our app is...
But how big is his dict? Will we be able to measure it?
It's really just a subject that takes a message. A subject can be thought of as an address, the way you want your messages to end up. You don't need to worry too much about the implementation details for this video, but let me know in the comments if you'd like a deeper dive into Gleam concurrency. The last type we need to define is the type of the messages we'll pass to our actor. The set and shutdown messages can be thought of as one-way messages. They tell the actor to do something and don't require a return value. The get and get keys, on the other hand, take a subject in their constructor, which is generic across the return type of that particular message, and allow us...
It's always really hard to show this level of code in a video because I'm trying to remember all the previous things and trying to add these new concepts into my brain. I always feel like if you just don't have the exact thing already in your head, this stuff just feels confusing to the average person walking in.
To send data back to the original process. So, sending a get message will return a result containing either the value at that key or nil if it can't be found. Lastly, we create a handle message function that takes in our message and our store, doing some work before allowing the actor to continue with the updated store. For get and get keys messages, we use process.send to send the result back to our client. The shutdown message just stops the actor. Finally, we create some functions to start a new actor using actor.start and to abstract away some message.
Right, with this previous code, effectively you could only have only one thing in the actor can be executing at one time. So there's some sort of queue that's behind it. That way you don't have multiple values going in at the same time. That's my assumption of what's happening here because they all call actor.continue. I think that's probably what's happening, and so I think that makes sense.
Send the result back to our client. The shutdown message just stops the actor. Finally, we create some functions to start a new actor using actor.start and to abstract away some message sending from the rest of the application. That seems like a lot. There's actually only 83 lines of code to allow us to create fully isolated caches in our app. We set up the caches in our main function and add them to a context type that gets passed into every request. Using the caches speeds up the app a lot and actually helps us stick to the Pokey API fair use policy. So it's a double win. Gleam and the Beam also have the concept of supervised in concurrency.
By the way, that is super cool how simple that cache was. I mean, I know we looked at it and we could all largely agree we didn't understand the cache, and plus their caching system is a relatively simple caching system. It's just Pokemon and its moves. So it's like a very one-dimensional cache. It's not like something that changes regularly. And so it's very simple to cache, and so I just loved that approach. That approach was super simple. It was straight to the point. Absolutely loved it.
which are processes that look after other processes. But I'll talk about those in the aforementioned concurrency.
By the way, that is something that I do think is so super good. Like if you can just realize how simple your caching is, you don't need to bring in an entire caching universe just to cache a simple request that doesn't change. You know what I mean? I absolutely think it's just wild how often over engineering happens. This was a perfect example of just engineering the problem, and that's it. It was beautiful.
Video. Make sure you subscribe so that you don't miss it. I also won't be going into the details of the Pokemon battle simulation in this video. It's very rudimentary and it's all fairly standard Gleam with nothing particularly noteworthy involved. If you want to take a look, the code is all on GitHub, and I'll probably also use this project as part of a full Wisp tutorial in the future. The /battle endpoint simply returns the winner of the battle between two Pokemon, making sure to use the cache to avoid unnecessary calculations. That said, we do have one other long-running process to talk.
Wait, hold on. Whoa. Are you saying that every single time you battle, you only battle once and that's that? Can't a battle, couldn't there be more than one result out of a battle? Isn't that like a possibility? Isn't there some level of stochasticness? Yes, critical hits. Yeah, wouldn't either you win or you lose. Yeah, but there's some level of stochasticness to it. You're telling me there's no critical, there's no Pokemon battles are deterministic? Well, then why would anyone ever play? There has to be, that's how Pokemon works, really. So there's never a competition. I assume there's no competitions ever then. You just walk in, everyone shows their cards, and they pick the one card that beats everybody, and then we all walk out. Is that like how Pokemon? Is that how Pokemon works? Yeah? Okay. That seems kind of crazy that they have whole ass days dedicated to a tournament that everyone just hands in their cards, and we just call that a day. No, you guys just told me it's deterministic. So, that's fine. That's okay. That's just how it works. That's because Pokemon is stupid. You just made so many people upset with that one statement. Let's go!
To avoid unnecessary calculations. That said, we do have one other long-running process to talk about, and that's the Battle Manager. Again, this isn't special. It's just a task that runs infinitely, calculating the results of the battles of every possible combination of Pokemon that we already have cached. I wouldn't recommend this for a production system, as the number of battles increases exponentially with each additional Pokemon.
It's quadratically, buddy. Exponential is when you have the n in the exponent, not in whatever you call the base number. I forget what the base number is called. What's that number? Yeah, n squared is just quadratic. Anyways, the base. I thought it was called the base. Okay, so I'm right. I just called the base. The Mantisa. You can't just use the term Mantisa. Okay, that freaks people out. All right, there's the exponent and the Mantisa. Okay, we're not gonna do that. Quadratic is exponential. Many people confuse quadratic and exponential functions because they both have an exponent in their equations. The key difference between quadratic and exponential functions is where the variable is located. Oh, looks like somebody's right. Looks like somebody else is wrong. And fuck yourself. All right, no, it's called quadratic because the variable's not there. That's why it's not exponential.
Pokemon, but it's a fun example for this video. And that's about it. As you can see, Gleam makes it really easy to write fault-tolerant, scalable APIs. The types...
Oh my goodness, this penguin is bothering me so much how it's laying bricks. Did you guys just see that? Look at it.
System is a big highlight. It's robust enough.
It put the bricks the long way? Who puts bricks that way? Who throws a shoe? Honestly, who throws a shoe? This is ridiculous. Stupid penguin.
Enough to allow you to make invalid states unrepresentable, but it's simple enough to not be a nightmare to work with or refactor. What do you think? Do you think you'll adopt Gleam in your future projects? Let me know in the comments. And if you decide to start using Gleam in production, make sure to try out the Codecrafters Gleam courses to help you get there. Want a more basic intro to Gleam? Well, I just so happen to have a video made just for you, and you can find it right here.
Boom. Go get it. Thank you for showing me. Look at that. Thank you for showing me my own videos. I like seeing my own videos. How great is that? That was great. I like that. I like that a whole bunch. Thank you, the PrimeGen React Reddit. I appreciate that. That was a great video. I do like the idea of having more Gleam in my life. I really do. I really genuinely do want more Gleam in my life. But at the exact same time, I'm a realist, and I realize I just want to do ASCII encoding. Okay, that's it. I just want to do ASCII encoding. That's all. That's what I want to do. Okay, and so therefore, I will not, in fact, be using Gleam. I will be just continuing on down the Go path, maybe checking out a bit of Zig. Okay, because Zig is really like the right way to do this problem. Is my guess. Zig is the ultimate of it because you can really control the allocations with Zig, and that's probably the way to go. You know, that's just what I'm saying. You know what I mean? You know what I mean? You know what I mean? Anyways, the name. You got to stay true to your desires, honestly. So a really good thing for you, everyone here, because I hear it all the time. How do I not get burnt out? How do I do all this? How do you program so much? Programming what you love for some amount of time a week will really help kind of give you the fury, the fire, the desire, the excitement that you need throughout the week. Because when you program really boring things and then you kind of develop this distaste for programming and then you don't address that problem and you just let it fester over and over and over again, you're just going to eventually build like an aversion. So you have to also be able to have fun, right? Like think about this. Imagine you played any professional sport, like let's just say basketball, but the only thing you could do was practice free throws. Like, you would hate basketball after, like, 2 months. You'd be like, dude, I've just shot 9,000, 100 million free throws. I just want to play the game. No, you don't get to play the game. We only shoot free throws around here, right? Like, it'd just be so dang boring. It's crazy. A gen.